Alright, so welcome to your next video. This one is about isotopes and ions, which are special types of atoms. So we're going to do a quick little review.
So just to remind you, protons and electrons are always going to be equal to each other when you're talking about a neutral atom. So like when you look on the periodic table and you see an element, those are neutral, so you have the same number of protons and electrons. So if you look at carbon, 6 protons, 6 electrons, because they cancel each other out. The number of neutrons, though, that can change without actually changing what you're talking about. So if you change protons or electrons, now you got something that's not neutral or that's not the exact same element anymore. But a neutron, you can add extra neutrons, take away neutrons, and it's still going to be carbon. That's why they have decimals after. Remember we talked about how if you have a decimal underneath there, that's the average of the mass, and it's because it's accounting for all the different isotopes that you might find out there for that specific atom. And usually we say that if you round it to a whole number, which is what we do, remember to get that mass number to be able to find protons and neutrons, it usually will represent the most commonly found isotope, although it doesn't have to, but it usually does.
Okay.
So real quick, what you're saying then is that 6 on the carbon there is the number of protons, and since it's an element on the periodic table that we're looking at, it's also the number of electrons because it's neutral. It's an element up there, right? So that 6 is the protons, and it's also 6 electrons.
Exactly. And if you took that 12.01, rounded to 12, subtract the atomic number 6 from it, that gives you 6 neutrons.
That's how we find neutrons.
Yep. So what I just mentioned about adding and taking away neutrons is what an isotope is. So isotopes are atoms of the same element that have different numbers of neutrons. So the easiest way to recognize if you have an isotope is when the element is followed immediately by a number. It's something called isotope notation. So the example we have here is like carbon 12 with a little hyphen, or C with a little 12 underneath it. What they're telling you is which specific type of carbon you have. So the number stands for the mass number, and the reason why we get this is if you went into your backyard, let's say in the wilds of the world, and you dug a hole and you pulled out a bunch of carbon, you would find that, and if you were to zoom in...
DNS Casino, please dial 4778.
Just keep rolling.
Yep. If you were able to zoom in super, super close and actually see the atoms, you would see that some of those carbon atoms are carbon 12 and some of those atoms are carbon 14. Now what's different about them is carbon 14 has 2 extra neutrons, but it has the exact same number of protons and electrons, and that's key because if I add or take away protons, now you completely change the element you're talking about. For example, if I added a proton to carbon, you wouldn't be carbon anymore. Now you would be
nitrogen, right?
Nitrogen,
Yeah,
right.
Which has 7 protons.
Exactly. But I can add and take away neutrons as much as I want to, as long as the atom's still stable, and it'll still be carbon.
Yep. So here's how we actually identify then the numbers of protons, neutrons, electrons in carbon, or carbon-16, excuse me, which is an isotope of carbon. First of all, the atomic symbol is just the same. It's C. The atomic number, still the same. It's 6.
That means 6 protons.
And?
And 6 electrons,
Right.
since it's neutral.
So the mass number is just that isotope annotation that's after the element there. That's 16. That's the mass number. Okay. That stands for protons plus neutrons in the nucleus. Okay. Now, as far as protons, as we talked about, the atomic number is always going to match up to protons. Okay. Neutrons now. Remember the way we found that? We took mass number, subtracted protons. So 16 minus 6 is 11.
10.
Oh yeah.
Let me check my calculator.
I think we got it.
It's 10. You're right.
And since it's neutral, then the electrons, let me guess, the electrons are going to be 6 also, because we don't change the amount of electrons in an isotope, right? Woo!
You
Big
are
math!
correct.
And I'm out.
All right. So
And I'll be right back.
really quickly, I'm going to show you how to do a Bohr model with an isotope using this isotope right here. If you could, please write this along next to this part of your notes.
Yep.
Alright, so on the left here, I have a Bohr model, which you guys have seen before, of carbon. It has 6 protons, 6 neutrons, 6 electrons. On the right here, though, we are going to do a Bohr model for carbon-16, which is an isotope of carbon. Now, any isotope is still going to have the same number of protons. If it had a different number of protons, it would be a different element. Okay, and this is a neutral isotope, so it is still going to have the same number of electrons as protons. The difference between an isotope and a regular atom is that there's a different number of neutrons. So here we had 6. Now to figure out the number of neutrons, we use our mass number, which is 16, subtract our protons, and you get 10 neutrons. So we got 10 neutrons. The only difference when doing a Bohr model with isotopes is you have to, when you write in the different particles in your nucleus, you're going to notice it's going to be different. Like you see, we got 10 neutrons here. as opposed to on this side. Okay, so that is the only major difference. Besides that, we have the same number of electrons, so our electron orbitals should look the same.
All right, and we're back.
Ooh, gosh,
My
you
arm
are
is tired
good
from
at this
holding it up
stuff.
the whole
I know.
time looking at that. That was incredible.
You are good, man.
Seriously. All right, ions. An ion, you guys, instead of changing the number of neutrons we have in the atom, we're going to leave those alone. We're actually going to change the amount of electrons that we have. So it does not have a neutral charge. An ion actually will have either a positive or negative charge, depending on if it either lost electrons or gained electrons.
Is that what those little like -1s and +2s always mean?
Yes.
Always confused me.
Because you don't
Makes
change the
sense
number
now.
of protons to get a positive charge. What you would do is say if you had, like, if you look at the case right there, Mg plus 2 would mean it lost 2 electrons. That means it lost 2 negative
Negatives.
charges.
Wait, so I can't make an ion by adding 2 protons?
No, because if you add protons or subtract protons, you're changing the element.
Oh.
Don't change the amount of protons. You do all of these positives and negatives by changing the amount of electrons, either adding them to get more negative charges or taking them away
Okay.
to get a positive charge.
Okay, makes sense. So should we try a practice problem with this?
Yeah,
I think so.
definitely. Let's look at
Okay.
that.
So right here we have bromine with a -1 charge. So, and you'll normally see, as you saw in the last slide, you will see ions.
Your attention, please dial 4778.
You will see ions with the charge right there in the upper right corner.
That's
okay?
called the superscript. I think,
Superscript,
right?
yes.
Superscript?
Super means above, sub means below. So subscript is lower.
Right.
But anyway,
That'll be
so
important next unit.
Yeah.
BR, just look that up on the periodic table. That's bromine. Okay?
Bro.
Now the atomic number.
Bromine.
I don't remember bromine off the top of my head. Hey, it's 35.
It's 35.
You are good, man.
Thank you.
So we don't memorize this. We just know
Anyway,
it.
the mass number, if you take that average atomic mass and you round it off, you would get 80.
That's a big mass.
It is.
Yeah, it is pretty hefty.
So, how many protons are there? Well, remember, if it's bromine, it has to have the same number of protons as
The atomic number.
that atomic number. Yeah, so it has to
So
be
35.
35.
Yeah,
Okay?
all bromines have those many protons.
Right? And the neutrons, you just take that mass number, subtract your protons, you're going to get 45 here.
You sure?
Yeah.
Oh,
Yes.
Good
I'm,
job.
I'm good
job.
at math. Besides that one I messed up earlier.
I can do this last one. Let me do this last one.
All right.
I totally got this. Okay, so bromine has a -1 charge. That means electrons are negative. So this bromine has 1 extra electron.
Right.
I think
If
so.
it was neutral, it would have the same number of electrons and protons. So that would be 35. But because it has an extra electron, it's actually got 36 electrons.
I
think
think
you're
you
right.
are absolutely right.
Yeah, and I'm out again.
All right,
Back
so,
because you guys need
Just
me.
stay away.
so remember,
I don't
the
blame you.
that negative charge, some people get this mixed up. They actually subtract an electron from your total number because they
Ooh,
see
that
that
would make it
-1, they go,
positive.
Right.
oh, -1. But actually it ends up being the opposite because to add a negative charge, you have to add an electron. So be careful about that. That's the biggest mistake I see students make.
Right.
Okay? So what I'm going to do is I'm actually going to show you how to make a Bohr model, not with bromine actually, but with a different ion because bromine would be a little too
That's a
large
long
of
one to
Bohr
do.
model. I want to do a
Yeah.
quick one. So write that Bohr model to the side of this little problem here on your notes as well.
All right, let's take a look at some fluorine Bohr models. So the one on the left is just your normal fluorine atom, and the one on the right is a fluorine atom with a charge of -1. Okay, so as you'll recall, every fluorine atom has to have 9 protons. If I change the number of protons, that means I have a different element. Okay. Next, neutrons, unless it says so, which it doesn't, you can assume that the number of neutrons is the same as it would always be. Okay. And then finally, the electrons is the tricky part. Remember, you have a charge of -1. What that means is there's got to be one more electron than proton. And you can't change the number of protons, so you can't just take away a proton and keep the same number of electrons, because that would change the element. You need to add an electron. So that means you normally would have 9 electrons. Instead, you have to add 1 to give it that -10 charge, and you have 10 electrons. So notice how you have 1 more than the protons, okay? Then after that, you just fill out your Bohr model normally. We got 9 protons, 10 neutrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Now you will notice the difference here is that I have an electron here and it is not on the normal fluorine atom.
And we're back. So we're almost done. Here's a few quick rules of thumb that we want you to add to the bottom of your
Yes.
notes, okay?
Write it down.
Some real quick rules about atoms. So I'll go with the first one, and then we
Okay.
kind of rotate around. All right.
Sounds good.
So first of all, whenever you change the number of protons to an atom, you change the element. So let's say I have hydrogen. It has 1 proton. And you add a proton to it. You do not have hydrogen anymore. You have helium.
Woohoo. And remember, when you change the number of neutrons to an atom, you make an isotope. You don't change the actual element. So like carbon has 6 neutrons normally. If I add another neutron to it, still carbon. It just has a bigger mass. It's a little heftier. Ate too many donuts.
Okay.
And another way that you can change an element or an atom and still keep it the same element is by changing the number of electrons. And if you change that number of electrons, you give it a charge. Positives or negatives will show up next to that elemental symbol, and that's called an ion when you change the number of electrons. That's it.
There you go.
Later.